Hi, y'all, and welcome to the 11B Day 1 notes. Today is all about the Pythagorean identity, which is this equation right here. But we'll get to that later. First, let's get back to the basics. This is from 11A. What do the ordered pairs on the unit circle represent? Those represent cosine, comma, sine. And here we're using theta. Theta is a variable that represents an angle. Hopefully we recall that the quadrants are numbered 1, 2, 3, and 4 in counterclockwise order. Our goal is to figure out the signs of cosine and sine in each quadrant. And to do that, we're going to remember that cosine goes with the x variable and sine goes with the y variable. And we know that on the right-hand side, the x values are positive, right? And those correspond with cosine, so the cosines are positive. On the left, x is negative, so cosine is negative. Likewise, with sine, above the x-axis, y is positive, so sine is positive, and below the x-axis, sine is negative. Now we're ready to use the Pythagorean identity that we talked about earlier. To use it, we are just going to plug in the given values and then solve for the other values. Ignore the quadrant until later. So for this first one, we'll write down our equation, but substitute our value for sine, which is negative 1/2, into our equation for sine. Don't forget to square it. Now we're going to get rid of the square. Remember PEMDAS, next thing is parentheses and exponents, right? So here, when we square it, a negative times a negative makes a positive. 1 squared is 1, and 2 squared is 4. So we're going to square each part of the fraction individually. Now we subtract 1/4 from both sides in order to solve for cosine. 1 minus 1/4 is 3/4, right? Now to get rid of the square, we're going to square root, which is the opposite of a square. Remember, we're going to do it on both sides, and we're going to do that on the numerator and denominator separately in order to make this easier. So we're left with cosine theta equals the square root of 3 over 2. We leave the square root of 3 on its own because it's not a perfect square. Now don't forget, we are always going to have a plus or minus when we take a square root. The plus minus means that we have two answers, a positive and a negative, but we only want one answer. So this is where we finally bring the quadrant into play. In this case, it's quadrant 3. And when we look at quadrant 3 on the graph, we notice that cosine, which is what we're finding, is negative. So we're going to take the negative value for our answer. And that's our final answer. Let's try it again on number 4. Here, we're going to be substituting sine, not cosine. When we square it, remember that the negative squared gives us a positive. 1 squared is 1, and 2 squared is 4. Now we solve just like before. So we're going to subtract 1/4 from both sides, which leaves us with 3/4. We're just trying to get the sign by itself, right? So we're moving everything to the other side. Now in order to get rid of the square, we're going to square root. I'm going to square root the numerator and denominator separately. And remember that our answer is going to have a plus or minus in it. Just like before, we're going to look at the quadrant, which is 3. And now we're looking for sine. Sine is negative, so our answer is going to be the negative answer, which means we leave the negative in our question. All right, try the rest of this page on your own. Remember, you can use a calculator, such as the one on the left, and you can use the proper fraction function on the calculators, which on this one is F2 and then 7, in order to make subtracting fractions easier for you. All right, let's move on to the back. So here, the difference is that we see a lot of pies. And when we see pies, we're going to think of radians when it has to do with this unit. We also don't have quadrants. But what we're going to do is use our radians to translate into quadrants. So we know that the graph starts at 0 radians, just like it starts at 0 degrees. We also know that a whole circle is 2 pi radians. So this part is 0 or 2 pi radians. Then half of it is pi radians, and a quarter of it is pi over 2 radians, and 3/4 of it is 3 pi over 2 radians. This is also written in orange on the unit circle itself. And we can use these to actually find our quadrants, all right? Because the quadrants are still on the graph, right? And now we just have a range. So for instance, for number 7, we see pi over 2 to pi, right? And if we look at our graph, that is this quadrant, which is the second quadrant. Similarly, on number 9, from 0 to pi over 2 is right here, so that's quadrant 1. So all we're doing is adding an extra step of having to translate radians into quadrants. We're now going to follow the same process using the Pythagorean identity by plugging in values, just like before. I'm going to speed through this part and stop when we get to the quadrants part. From here, we're just going to look at quadrant 2. Now, a trick here is to look and see that cosine values, which are the x values, are all negative. So we know our answer is going to be negative. All right, so again, go ahead and do everything up to the quadrant in number 9. Now we're going to look back and see 0 to pi over 2 is in quadrant 1. And in quadrant 1, the sign values, which are the y values, are all positive. So we know our answer is going to be positive. Go ahead and try the next two out, and then you can check your work. All right, then. That's all we have, and I will see you for 11B2 in a little bit. Have a good day, y'all.